Shout it out.
I've been studying star formation for most of the time I've been at Smith. And our understanding of this process has changed dramatically over those decades. I'm now counting in decades since I've been here. And when I first began this kind of work, we knew that there were stars that were young, and they seemed to be sort of, I'm going to say, hyperactive, like adolescents. And we thought that all that activity was coming because the stars just hadn't really settled down. And then over the decades, as time went by, I don't want to go through all the history of it, just jumping into our modern understanding, it's very clear that when we look at the process of how stars form from these giant clouds of molecular gas in the galaxy, that stars and their planetary systems are all forming together. And there's quite a fascinating process for how that all works. You start off with, if you look in the galaxy, most of the visible matter that you can see is light from stars. And so the stars, but about 10% of the matter in the galaxy that we can see with radio telescopes are these gas clouds, just gas and a little bit of dust. But there's a lot of material there just spread out. And then there'll be a little denser than average clump that'll just start to collapse from gravity. Gravity begins to pull it together, but it's also spinning. So in addition to getting smaller, it's spinning and it kind of flattens out into a pancake shape. And that little pancake shaped thing in the center is the protostar, what's going to turn into a star, and surrounding it is what we're now calling a protoplanetary disk. And we didn't see the disks back in the early days because you have to observe them with infrared and radio telescopes that we weren't using at that time. So we were just looking at the optical light from the star, the visible light, where we see all this activity. Now we know that that activity wasn't from the star, but it's material from the disk falling onto the star like this, and there's jets of stuff coming out. But with respect to what's the bigger implication that everybody should care about, the bigger implication is it's very clear now, every time a star is formed, the same basic process is involved. Sometimes it'll turn into two stars, sometimes it'll turn into one star. But whether it's one or two stars, there's a disk of swirling material around it that will turn into a planetary system. But my own work is just right there at the protoplanetary disk stage. In my current project, I'm studying the way in which the disk itself is throwing material off into space. Some of it is being assembled into planets, but there's a lot of material that doesn't go into planets, and it's got to be cleared out because our solar system is not full of a bunch of junk. So we used to think a wind from a star blew it out, but now it looks like it's like the disk is blowing out a wind itself. And so I'm studying that wind and trying to understand how that works. I've had students from Smith working with me on various aspects of this project. And absolutely, some of them have gone on to graduate school in astronomy. Some have become PhD astronomers already. If I just look at the students that I've been working with in just the most recent years that have done honors thesis projects with me, one of them is now at Arizona State University. This is Wanda Fang, and she worked with me on the protoplanetary disks around young stars, and now she's looking at disks around dying stars. Called white dwarfs, but she can take a lot of the knowledge that she developed working on the young stars and now apply it. So that's very fun. Another student who worked with me very closely on a lot of the material that's falling from the disk onto the star actually became a high school physics teacher at the Northampton High School, and she's doing an outstanding job. And she's sending a lot of her students to come take astronomy classes with me. So we've stayed in very close touch. And another one has gone off to be a teacher at a private school in Connecticut. So those are the ones I've worked with most recently. But students who hadn't worked with me but were astronomy majors we've got one at graduate school at Santa Barbara. We just had one graduate from Princeton a little while ago. Yeah, so there's quite a lot of astronomers out there that have their roots at Smith College. And it's very fun to go to a professional astronomy meeting and to pull together the Smithies from many different, eras.